everyone, welcome back to ReMathable. Today I'm going to be talking about transformations. What exactly is transformation? So, transformations are actions that cause changes to shapes and figures. Now, as per our syllabus requirements, there are four distinct transformations that we need to know: reflection, rotation, translation, and enlargement. Now, I've decided to make a whole series where I discuss each type of transformation separately. So, in each video, we'll focus on one kind of transformation at a time. And then eventually, in the last video, we will practice past paper questions where we will combine all the four transformations together. In this video, we're going to focus on reflection. But before we discuss it, let's discuss some of the key terms that we're going to use in this topic. So, triangle ABC is transformed or mapped onto triangle A prime, B prime, C prime. Okay? So the first thing that you need to know is the figure that is transformed is called the object. Okay, so what is an object? The figure that is transformed. Is called the object, and the resulting figure, the one which has been transformed, the resulting figure is called the image. So what is the image? It is the resulting figure. Okay, so the figure that is transformed is called the object, and the resulting figure is called the image. And how do we say this? We say that an object is mapped onto an image. So this is called mapping. So the object is mapped onto the image. Okay, so what are the key terms here? It's object, image, and mapped. And we denote the mapped image or the point. So for example, A is the object point and the mapped point is often denoted by this prime. So this prime, okay? So A is mapped onto A prime. B is mapped onto B is mapped onto B prime. C is mapped onto C prime. Okay, so we are going to use the same key terms for all four kinds of transformations. Okay, another important point that you should, another important key term that you should be aware of is the invariant point. Now, what is an invariant point? An invariant point is a point that remains in the exact same position even after a geometric transformation has been performed. Okay, so let's first write it down and then I will explain it through this visual example. So an invariant point is a point that remains in the exact same position after a transformation. So let's look at this example. So triangle A is mapped onto this green triangle. Let's call it A prime. This is A prime, okay? So this is our object and this is the image. Now, we will get into the details of this reflection later. But see, this point has been mapped onto this point, right? This point has been mapped onto this point. What about this third point? So even after the transformation, the point remains the same. So this point onto this point onto this point, and this point remains the same. So this is an invariant point. Okay, so a point that remains in the same position even after the transformation is called the invariant point. Now let's begin with our first transformation, that is reflection. An object can be reflected in a mirror line to produce an image, right? So an object in a mirror line to produce an image. Now the image, so let's, for example, let's say we have triangle. This is our object. And this is the image, okay? And our line of reflection is this. Okay, so triangle A is mapped onto triangle A prime. Now you need to keep in mind a couple of things. Firstly, the image is always exactly the same shape and size as the object. So same shape, same size as the object, but the image faces the opposite direction. A mirror line acts very much like a real mirror. When you look in a mirror, you see your reflection, which appears to be the same distance between the mirror as the distance between you and the mirror, right? And a mirror line can be any straight line on the coordinate plane. We will discuss the different types of mirror lines just in a bit. But in everyday language, we might say that the object is flipped over to create the image, right? The position and orientation of an object may change, but its shape never changes in reflection. A point on the image and the corresponding point on the object are exactly the same distance from the mirror line. So let's look at these 2 points. So 2 units from the mirror line, and similarly this point is also 2 units from the mirror line. Let's have a look at this one. So 1, 2, 3, 4, 5, 6 units from the mirror line. This is the corresponding image point. So let's count the distance till the mirror line. So 1, 2, 3, 4, 5, 6 units. So this is 6 units away from the mirror line, and so is the image point. Okay, let's have a look at this object and its image. Okay, so this is the mirror line. We have a vertical mirror line in this example. And let's have a look at the object points and the corresponding image points. So let's first have a look at this first point. So how far is it from the mirror line? 1 unit. And what about the respective image point? It is also 1 unit away. Let's have a look at the second point. So 2 units from the mirror line. Similarly, 1, 2 units from the mirror line. The third point, 1, 2, 3 units from the mirror line. This is the respective or the corresponding image point. So let's calculate the distance of this point to the mirror line. 1, 2, 3. So this is 3 units and this is 3 units. Okay, I also want you to notice that when you have a vertical mirror line, the distance that you calculate is horizontal, right? So for all the points, you're calculating the distance horizontally as you move horizontally along this plane. Okay, what happens if the mirror line is a horizontal line? So let's have a look at this point first. So let's calculate its distance from the mirror line. So it's 1 unit. But please notice that we are counting the distance vertically. So in case of a vertical mirror line, we count boxes horizontally. But when we have a horizontal mirror line or line of reflection, this is also known as the line of reflection or the mirror line, same thing. Okay, we count the distance vertically. Okay, so let's mark all the points. 1, 2, 3, 4, 5, 6 points. So we need to reflect these 6 points along this line of reflection. Okay, so let's start with number 1. So 1 unit vertical, 1 unit here. So this is going to be, let's use a different color. Okay, so this is, let's call this A, B, C, D, and E. Okay, so this is A prime. Now let's have a look at B. So 1, 2, 3, 3 units to the mirror line. 1, 2, 3, 3 units here. So this is going to be B prime. Let's have a look at C now. 1 unit, 1 unit, 1 unit here. So C is going to be, C prime is going to be here. Let's count the distance of D. 1, 2, 3, 1, 2, 3. So D is going to be, D prime is going to be here. Before E, okay, so let's call this E and this F. Okay, what about E? 1, 2, 1, 2. So E is going to be here. And what about F? Since F is on the mirror line, it will remain here. And therefore, F qualifies as the invariant point. Any point on the mirror line will be an invariant point. Let's draw the image now. Connect A with A prime. A prime with B prime, B prime with C prime, C prime with C, D prime with E prime, E prime with F, and this A. Okay, so this is our object, and this is the corresponding image when reflected along this horizontal mirror line. Okay, so we've discussed vertical mirror lines and horizontal mirror lines. When we have vertical mirror lines, we measure the distance horizontally. When we have horizontal mirror lines, we measure the distance vertically. Now we're also left with one last case where the mirror lines are slanting lines. Okay, in this case, we measure the distance diagonally. So if we have slanting lines, slanting line of reflection, we will measure the distance from the object to the mirror line diagonally. So this is half a diagonal, right? This is one complete square, so this will be half. So half square to the mirror line. Let's calculate half square from the mirror line. So this is, if this is point A, this is A prime. Okay, now let's have a look at this point. So let's calculate the distance or measure it moving diagonally across squares. So 1 and then 1. So this is point B, this is B prime. Let's calculate the distance of the third point. 1, 2, 2.5, half, 1.5, 2.5. Okay, so C and C prime. So I hope that you are clear that if we have a horizontal line of reflection, we will measure the distance vertically. If we have a vertical line of reflection, we will measure the distance horizontally. And if we have a slanting line of reflection or a sloping line of reflection, we will measure the the distance diagonally. Okay, let's do an example to put this into practice. Okay, so let's label the points A, B, C, D. Okay, and since we have a diagonal line of reflection, we will calculate the distance from a point to the reflection line of reflection diagonally. So 1, 2, right? 1, 2, 1, 2. So this is where A prime is going to be. Let's look at B. 1, half, half, 1. So B is going to be here, B prime. And please notice that points C and D, they lie on the line of reflection, so they qualify as the invariant points. They will remain there even after the reflection, right? So your reflected image is going to be this. Okay. Now there are 4 standard types of reflections that I'm going to discuss before I move on to other cases. The first is reflection. Reflection in the x-axis, reflection in the y-axis, reflection in the line y is equals to x, in the line y is equals to x, and reflection in the line y is equals to negative x. Okay, so we are first going to discuss these 4 standard cases, and then we will move on to other general cases. Okay, so let's imagine that we have a triangle PQR with the following coordinates. So P is 2, 1, Q is 4, 1, and R is 4, 4. So they've been listed here. The first case that we're going to discuss is reflection in the x-axis. So I hope everyone knows that this is the x-axis. So basically they're asking for a reflection of triangle PQR in the line in the x-axis. Okay, so so this is our line of reflection. Okay, we have a horizontal line of reflection. So reflection okay, so wait, let me change the color. Okay, reflection in the x-axis. Okay, since x-axis is a horizontal line, we will count or measure the distance vertically. So 1 unit, right? So this is going to be P prime. 1 unit, 1 unit. This is going to be Q prime. 1, 2, 3, 4. 1, 2, 3, 4. So this is going to be R prime. Okay. So let's note down the coordinates of P prime, P prime, Q prime, and R prime. So P prime is 2, -1, 2, -1. Q prime is 4, -1, 4, -1. And R prime is 4, -4. 4, -4. Okay. Now, if you notice here, can you figure out what is happening, or can you figure out basically a rule that we can apply to find these image points when they are reflected in the x-axis? Okay, so see, our x coordinates, they remain the same. And what happens to the y coordinates? So this is 1, this is -1. This is 1, this is -1. This is 4, this is -4. So what is happening? Only the sign of your y coordinate has changed. So whenever you reflect along the x-axis, the rule that you can derive is that the sign of the y coordinate will change. Okay? So the object, so for example, if the object is xy and you reflect along the x-axis, what happens is that the sign of the y coordinate changes. Okay? I hope everybody can see this clearly. So even though we can also find the image points graphically as we were doing previously, but if you in the paper, if you get a reflection along the x-axis, you can save yourself time by remembering this rule. Memorize it. I think it can come in very handy. So you know that all you have to do is change the sign of the y coordinate and you get a reflection along the x-axis. Okay? Okay, now let's have a look at reflection in the y-axis. Let's use a different color. Okay. Reflection in the y-axis. Okay, so what is the y-axis? This is the y-axis, right? Okay, so when we have a vertical line of reflection, we measure the distance horizontally. So 1, 2, 1, 2. Let's call this reflection P double prime. Okay, so it's going to be, oops. P double prime. Okay, let's look at Q. 1, 2, 3, 4. 1, 2, 3, 4. So Q double prime. 1, 2, 3, 4. 1, 2, 3, 4. So this is R prime. Okay, so let's connect the points. Okay, and let's write down. So P is 2, 1, Q is 4, 1, and R is 4, 4. Let's write down the coordinates of P double prime, Q double prime, and R double prime. So P double prime is minus 2, 1. Q double prime is minus 4, 1. R double prime is minus 4 and 4. Okay, and I hope before even I ask you to figure out the rule here, you've done that already. So let's have a look at the y coordinates, 1, 1, 4, 1, 1, 4. So the y coordinate is the same in this case. And what has happened to the x coordinate? So here we have 2, negative 2 here, 4, negative 4 as the image point, 4 and negative 4. So when you reflect along the y-axis, what is the rule that you can derive? So xy, when reflected along the y-axis, what happens is that the sign of the x coordinate changes and the y coordinate remains the same. Okay, so these are some handy rules that we are going to try and memorize, as they are going to help us save valuable time in the paper. So when you reflect in the x-axis, all you have to do is that you have to change the sign of the y coordinate. When you reflect in the y-axis, you just change the sign of the x coordinate and everything else remains the same. Okay, the third case, reflection along the line y is equals to x. So if you have vertical and horizontal lines, they're very easy to plot. Whenever they give you the equation of a slanting line, I hope everybody knows how you're going to plot that line on the graph. So what you do is that you draw a table and take some random values of x. So let's say -1, 0, and 1. And you substitute these x values into the equation and find the respective y values. So if you substitute x is equals to -1, y is also -1. If x is 0, y is also 0. If x is 1, y is 1. So this was obviously comparatively a simpler line of equation. Let's plot these points on the graph. So -1 is here, 0, 0 is here, and 1, 1 is here. Okay, so let's draw this line. Okay, so this is the line y is equals to x, and it is the line of reflection in this question. Okay, so now since we have a slanting or sloping line of reflection, we are going to calculate the distance diagonally. Okay, so let's see. Let's first measure the distance of P, the distance between P and the line of reflection. So half a square, so half a square. So this is where P prime is going to be. So this is P prime. Let's calculate for Q. So 1, 1. This is Q prime. Let's have a look at R. So half a square, half a square. So this is going to be R prime. Let's connect. Okay, so let's note down the coordinates. So P was 2, 1. Q is actually, it is 3, 1. And R is 3, 4. Okay, and what are the coordinates of P prime, Q prime, and R prime here? P prime is 1, 2. Q prime is 1, 3. R prime is 4, 3. So can you figure out the rule here? So P was 2, 1, P prime is 1, 2. Q was 3, 1, Q prime is 1, 3. 3, 4, 4, 3. So what is happening here? X and Y coordinates are being interchanged. They're swapped, right? So when you reflect XY, the coordinate XY along the line Y is equals to X, what happens is that the image is basically the opposite. So the X coordinate becomes the Y coordinate and the Y coordinate becomes the X coordinate. So we swap the X and Y coordinate. Okay. Let's have a look at the fourth scenario, which is reflection along the line Y is equals to negative X. Okay. So again, what we're going to do is that we are going to construct this line. So if X is negative 1, so Y is negative X. If X is negative 1, Y will become negative, negative, positive, Y will become 1. So if X is negative 1, Y is 1. If X is 0, Y is 0. And if X is, this should be positive 1. So if X is 1, Y is equals to negative X. If X is 1, Y will be negative 1. So let's plot these points on the graph. X is negative 1 and Y is 1. This is the point 0, 0 and then 1, negative 1. Okay, let's plot this line. Okay, so this is the line Y is equals to negative X. Okay, and we are going to reflect triangle PQR along the line Y is equals to negative X. So let's calculate the distance of P from the line of reflection. 1, half, half, 1. So this is where P prime is going to be. So P prime, double, let's call it P double prime. Let's have a look at Q. 1, 2, 1, 2. This is where Q double prime is going to be. And let's have a look at R. So 1, 2, 3, half, half, 1, 2, 3. This is where R double prime will be. Okay. So let's okay, so this is the image of reflection of triangle PQR along the line Y is equals to negative X. Okay, so the coordinates of triangle PQR are as follows. And when they're reflected along the line Y is equals to negative X, what do we get? So what are the coordinates of P double prime, Q double prime, and R double prime? So P double prime is negative 1, negative 2, negative 1, negative 2. Q double prime is negative 1, negative 3. And R double prime is negative 4, negative 3. So I will give you a couple of seconds to figure out the rule here. So 2, 1, negative 1, negative 2. 3, 1, negative 1, negative 3. 3, 4, negative 4, negative 3. So what is the rule here? So if you're sharp enough to notice that basically let's forget about the signs for a moment. So we have 2, 1 here. And when they're reflected along the line y is equals to negative x, we get 1, 2. Forgetting about the signs for a moment. 3, 1, 1, 3. 3, 4, 4, 3. So what is happening here? First, the coordinates are being swapped. That is the first thing that we can notice. So xy becomes yx. Now let's have a look at the signs. So all of these are positive, while all the coordinates here, xy included, they're negative. So basically a negative sign is added with the coordinates. So what is happening? The coordinates are being swapped and the signs are being changed. Okay? So these are the 4 standard cases, and if you come across reflection in any of these 4 cases, I would highly recommend that you memorize these 4 rules, as they're going to help you save time in the papers. So in the summarized form, we can say the object, the mirror line, and the image. So if we have coordinate xy and it is reflected along the x-axis, the image point is going to be x and negative y. So the sign of the y coordinate changes. If we reflect the point xy along the y-axis, I hope we remember that we just changed the sign of the x coordinate. If we reflect the point xy along the line y is equals to x, what happens? We swap the coordinates. And if we reflect xy along the line y is equals to negative x, not only do we swap the coordinates, we also change the sign of the coordinates. Okay, so these are 4 handy rules that I think can save you a lot in terms of time. Now what happens if a reflection comes from a line other than these 4 cases? So what are the 4 cases? Reflection along the x-axis, reflection along the y-axis, reflection along the line y is equals to x, and along the line y is equals to negative x. So if a reflection case comes which is along a line other than these 4 cases, you have to follow the same steps. The first step is that you need to draw the line on the graph. And how do you plot a straight line? You construct a table with random x values and you find the respective y values and plot them on the graph paper, and you will have your line right there and then. Sometimes the line can be a vertical or horizontal line. I hope that your basics of coordinate geometry are absolutely clear before you delve into transformation. So you should know that vertical lines always have equations in the form x is equals to a constant, while horizontal lines are always in the form y is equals to a constant. And for slanting lines, you construct this table and then plot the line on the graph. Okay, so x is equals to a constant will always be a vertical line. Y is equals to a constant will be a horizontal line, and y is equals to mx plus c is going to be a slanting line, in which case you are going to construct this table and then draw it on the graph paper. So once you have the line of reflection on the graph paper, everything becomes simpler. All you then have to do is count boxes and draw the image points. Okay, so in case you have a vertical line, you will count boxes horizontally. if you have a horizontal line of reflection, you will count boxes vertically. And if you have a slanting line of reflection, you will count boxes diagonally. Okay, so in the question paper, or in the paper, the question is sometimes structured in a way where they've given you the object and the image, and they ask you to identify the type of transformation that has been performed on the shape. So because we're doing reflection currently, I think it would be very easy for you to figure out that the transformation is reflection. But once you're done with all the 4 types of transformations, reflection, rotation, translation, and enlargement, I will also teach you how to identify the type of transformation being performed on a particular shape. Okay? And then after identification, they ask you to describe the transformation. So in all the 4 cases, I will tell you what specific points you need to include in order to gain full marks for the description of the transformation. So in case of reflection, what you need to write down is, to describe reflection, you need to write down the equation of the line of reflection. Okay, so let's have a look at this example. Here they've given us the object and the image, and they're asking us to find down the equations of the lines of reflection. Okay, so let's have a look at E first. Okay, so this is a vertical line of reflection, and we know that vertical lines always have the equation in the form x is equals to a constant. So the line of reflection will be in the form x is equals to a constant. And what constant is that? So extend the line of reflection and you see that it intersects the x-axis at 7. So the line of reflection is going to be x is equals to 7. Okay, so it's going to be x is equals to 7. Now let's have a look at Z. So we have a horizontal line of reflection. Horizontal lines of reflection or horizontal lines have equations in the form y is equals to a constant. So let's extend this line to see where it crosses the y-axis. It is at 3. So your line of reflection is going to be y is equals to 3 here. Okay, and now let's have a look at A. So this is a slanting line. So coordinate geometry is going to come into play here. We know that slanting lines have equations in the form y is equals to mx plus c, where m is the gradient and c is the y-intercept. Okay, so if we extend the line, we see that it crosses the y-axis at 0. Okay, so the value of the y-intercept or c becomes 0. Now all we are left with is to figure out the value of m or the gradient. Okay, and I hope all of us remember that the formula for calculating gradient is y2 minus y1 over x2 minus x1. So to find the gradient, we need any 2 points on the line of reflection. Okay, so let's see. We can choose 5, 5 and we can choose 3, 3 or any points that you want. You can also choose 0, 0. So let's choose 5, 5 and 0, 0. So 5, 5 and 0, 0. Okay, so 5, 5 and 0, 0. Okay, so let's assume this is x1 and y1 and this is x2 and y2. Okay, so the gradient is going to be m is going to be y2 5 minus y1 which is 0 over x2 which is 5 minus x1 which is 0. So m becomes 5 over 5. So the gradient of this line is 1. So y is equals to mx plus c, where m is 1, c is 0. So the line becomes y is equals to x. Okay, so that is how you find the equations of the line of reflection. Okay, so in case of vertical lines, your equation is going to be x is equals to a constant. The constant is the x-intercept of the line. Horizontal lines will be in the form y is equals to a constant. The constant will be the y-intercept. And in case of slanting lines or sloping lines, you are going to find the y-intercept by extending the line and seeing where it intersects the y-axis, and then finding the gradient using the formula y2 minus y1 divided by x2 minus x1. And y2, x1, y1, x2, y2 are basically any two coordinates on the line of reflection. So that is your choice. You can choose any 2 points on the line, and then you have to find the value of the gradient and then substitute it in this general form to find the value of, or the equation of, the line of reflection. So basically this is how you find the equation of the line of reflection. And if in the question they give you the object and its image and they ask you to construct the line of reflection, then one way to go about it is finding the line of equation, plotting it on the graph, and your line of reflection is right there and then. But what if you're not given a graph paper and it's on a plain paper? So the image and the object, they're on a plain paper, and they ask you to construct the line of reflection. So you should know that, but before I explain that, I hope all of us are aware of what a perpendicular bisector is. What is a perpendicular bisector? A perpendicular bisector of a line segment or of 2 points is basically a line that divides a line segment exactly into 2 halves, forming a 90-degree angle at the intersection point. Okay, so let's have a look at this object point, and this is the respective image point, right? So if you connect these 2 lines, I hope you can see that the line of reflection is basically a perpendicular bisector of these 2 points. So a perpendicular bisector intersects the line at 90 degrees, and then it also divides the line into 2 equal halves. Okay, so the perpendicular, so this is equal to this, right? And this holds true for any 2 points. So this is the object and this is the respective image point. So see, the line of reflection is the perpendicular bisector of this line. So if you want to plot or construct the line of reflection, you should know how to draw the perpendicular bisector of a line joining 2 points. What are those 2 points? The object and its respective image point. So if you construct the perpendicular bisector, you will get the line of reflection. Now you should first know how to construct a perpendicular bisector. So let's say this is point X and Y is the image point, or let's write it as X prime. Okay, so this is X and this is X prime. So with a very light pencil, you connect the image and the object point together and get ready to construct the perpendicular bisector. So how do you do that? So you take the compass and you should open the compass to a length more than half of this line. So any length, but more than half, okay? And then you place it on the first point and make arcs above and below the line. And now you cannot change the length of the compass. So that is going to remain the same. You're going to pick up the compass from point X and place it at X prime. So you place it at X prime. So this is X prime. You place it at X prime and then construct arcs above and below the line from this point. Please make sure that the length of the compass remains the same. Once you've constructed the arcs, the points of intersection of the arcs, so you have this point of intersection and then this point of intersection, and you connect it using a ruler. So this is how you construct a perpendicular bisector. Okay, so you join the points of intersections of the arcs using a foot ruler, and you will have your perpendicular bisector, which will actually be the line of. So I'm quickly going to demonstrate how you can construct a line of reflection. So let's imagine that this is point A and A prime is the image point. I've connected it. So you open up a compass and you need to open it to a length which is more than half. Okay, it can be any length, so you can open it more than half, as long as it is more than half, and then you're going to lock the length of the compass. You cannot change it now. Okay, so what we're going to do is that we're going to construct arcs above and below the line, right? Then we're going to pick up the compass, place it at the other point, at the other end point, and construct arcs from that point. Okay, but you have to make sure that the length of the compass remains unchanged. Okay, so now look at the points of intersection of the arcs and connect them using a straight line. Okay, so this is the line of reflection, a perpendicular line which divides the line segment into two equal parts. Now to summarize very quickly as to what we've covered in this video so far is that there are 4 standard cases with respect to reflection. They can ask you to reflect a shape along the x-axis, the y-axis, the line y is equals to x and y is equals to negative x. And these are some of the rules that we've derived which will help us save time in the exam. Okay, so if they ask you to reflect a point along the x-axis, all you have to do is change the sign of the y-coordinate of the object point. If they ask you to reflect it along the y-axis, all you have to do is change the sign of the x-coordinate. If you reflect it along the line y is equals to x, you swap the coordinates. And if you reflect along the line y is equals to negative x, not only do you swap the coordinates, but you also change the sign of the coordinates, right? And that way you will be able to get to the image points very quickly. If they ask you to describe the transformation, in this case reflection, you're going to describe it by finding and writing down the equation of the line of reflection. After doing that, you are going to draw the line of reflection, and you can draw it using the equation that you found, or you can construct the line of reflection using the perpendicular bisector of any object point and its respective image point. So you're going to get to the same line of reflection no matter what point of the shape you use, as long as you're using the object point and its respective image point. Okay, so all points will get to the same line of reflection. And then once the line of reflection is on the graph paper, and if the line of reflection is not from these 4 standard cases, then you can just count boxes vertically, horizontally, or diagonally. We've discussed each case in detail in the video. But if you have any confusions, please rewatch it and make sure that there are no confusions left unaddressed. And if there is something that still confuses you or you still don't understand, please feel free to comment and I will get back to your concerns as soon as I can. And that's it for today's video on reflection. take a second to think about how reflection shows up in the real world. So, mirror, water, even the way we see ourselves, right? In the next video, we're going to take things one step further and explore rotation. And if you enjoyed this video, make sure to like, subscribe, and hit that notification bell so you don't miss the next part of the series. Thanks for watching, and keep reflecting not just your shapes, but also your growth. Take care and see you in the next one.